So, good morning, everyone. My name is François Parcy. I work in the research department at Aereco. I first want to thank you all for being here today for this webinar on installation, maintenance, and long-term performance of our humidity-controlled exhaust units. This presentation was initially given at the AIVC conference last month by my colleague, Stéphane Bertin, who is here with me today. This will be the outline of my presentation. I will start by explaining the context of the study and where the data comes from. I will describe the system and the components, present the results, and our conclusions. The way we will proceed for questions is the following. You can ask questions in the chat during the presentation. My colleague will order them, and we will answer them after the presentation. We should have about 15 minutes left for this. So let's start with the context. Humidity-controlled ventilation was invented in the early 80s by the founder of our company. It has spread a lot since then, thanks to its thermal performances, which are recognized and valued in thermal regulations in France, as well as in other countries in Europe. Before generalizing the system as a reference in thermal regulation in 2006, the French Ministry for Housing wanted to test the performances of units after prolonged in-situ functioning. So it mandated the COSTIC laboratory to collect and test units that had been installed in occupied dwellings for long periods of time. Aereco took part in this study. I will present the results here, along with additional statistics on the installation. So let me present the system first. This is a schematic of a multifamily building. In 3, here on the roof, a constant pressure fan puts the dwelling in under pressure. So the air enters the housing via air inlets in the dry room, that's number 1. It circulates in the house via the undercuts and exits the dwelling via the service rooms via exhaust units located in number 2. Today, we will focus on these exhaust units only. You can see here on the left an exploded view of a typical product. Part 6 on the drawing is a hygroscopic sensor and actuator. It is made of several nylon strips that extend and retract when absorbing and desorbing humidity from the environment. Doing this, it opens and closes a shutter, controlling the airflow crossing the unit. You can see here on the right a typical hygroscopic characteristic with the fabrication tolerances. The manufacturer controls the minimum and maximum airflows as well as the reaction range. So the characteristic is adapted to the type of room and the size of the housing it is meant to be installed in. So we have no electronics, it is fully mechanical, and we control the airflow depending on the level of humidity in the room. I would just like to add, because it's important for the next few slides, that part 2 and 3 on the left drawing are removable and washable. That is all the maintenance there is to do with these devices. For this study, 21 social housings in the Parisian suburb were selected by the COSTIC laboratory. The installation was 6 years old. Neither Aereco nor the COSTIC was involved in its realization back then. All the exhaust units were photographed before being collected, and this collection stage was a good occasion for simple statistics on the installation and the maintenance level of the units. That's the first set of results I will present now. Let's start with the installation. What we found out is that 12% of the exhaust units were installed in the wrong room, meaning, for instance, a kitchen unit was installed in a bathroom. 6% were not in accordance with the dwelling size. By that I mean that units designed for a 5-bedroom apartment were installed in a 3-bedroom apartment, for instance. As a whole, 55% of the dwellings presented one of these nonconformities. So this was installation. Let's speak about the occupant's maintenance. In addition to this installation problem, we have seen degradations by the occupants on 5 out of 33 collected units. These degradations are sometimes voluntary, like in this case. You can see that the occupant blocks the shutter with a match. Of course, there is no modulation in this case. And sometimes the degradation is not voluntary. In this case, the occupant disassembled the product, probably for maintenance, and did not reassemble it correctly. In total, 4 out of the 11 dwellings presented degradations of the unit by the occupants. This pie chart represents a classification of the level of maintenance of the collected units. In blue, we find the 14% of deteriorated products I just talked about. Then we have sufficient maintenance in orange, that's only 11%. Insufficient maintenance in gray, that's 43%. And absent or close to absent maintenance in yellow, that's the remaining 32%. So in total, 75% of the collected units presented a lack of maintenance. In terms of number of dwellings, that's about 90%, so the vast majority. Just so you understand what we mean by these levels of maintenance, I present here a couple of pictures. On the top, you can see the product with the grill. At the bottom, we removed it. The unit on these pictures is reasonably clean. We classified it as sufficiently maintained. This one is more dusty, with partial clogging of the canal. It was classified as insufficiently maintained. This last one is clearly not maintained. The grill and the shutter are dirty, and the canal is partially obturated. These examples were taken from bathrooms, so the dust you can see is rather dry and fibrous. In kitchens, the dirt is usually more greasy. You can see here other kinds of units that were collected at the same time in complement to this study. These devices were installed in the dressing rooms. They are auto-adjusting units, meaning they don't react to any pollutant, but they are designed to have a constant airflow independently of the pressure in the duct. I will not go into details for the maintenance because it is not our subject here, but you can see that the 3 levels were also observed. Once the units were collected, we characterized them twice in our laboratory. A first time as collected, meaning without any cleaning or maintenance by us, and a second time after a proper maintenance. The next few slides are all about examples of these 2 characterizations and their comparison. To give you an idea of what a typical characteristic looks like, this was plotted with a new product. The minimum airflow is about 7 cubic meters per hour, maximum is 54. The range of reaction to humidity is between 30 and 70% relative humidity. The examples I will present now are representatives of the unit before classified as not maintained. We choose this category because it is the most critical one. This is what the product looked like when we first characterized it before the cleaning. This is a kitchen unit, and as you can see, there is a big difference with the bathroom unit I showed earlier. As I said, the dirt is more greasy. And this is the back side here on the left, and on the right you can see the nylon strips. You can see that there is a little dust deposited on the sensor. Here the characteristic as plotted on our test bench. There is a clear reduction of the maximum airflow, in this case by 27%, from around 70 cubic meters per hour to 47 cubic meters per hour. We attribute this reduction to the obstruction of the canal by the dirt. But still, you see that the unit is reacting to humidity. When the air is really dry, the airflow is well adapted to the requirement, and when there is an episode of high humidity, like someone cooking for instance, the airflow will increase. Well, not as much as it should, but it will stay up here until the humidity is evacuated, which will take longer. When the episode is over, the airflow comes back to its initial state within the tolerances. And here it gets a little more complicated, I'm sorry about it. So some of the exhaust units were in such a bad condition that we considered them beyond maintenance. So what we did is we changed the removable parts as I shown earlier, meaning the shutter and the grill that you can see here on the right. These parts do not influence the hygroscopic behavior, but only the minimum and the maximum airflows. The nylon strip, which defines the range of reaction to humidity, was left unchanged. The problem was the installation took place 6 years before, so the regulation changed between the installation and the collection stage. The airflow of the new products had to be adapted in consequence, of course. So we had to use new versions of the shutter case, and this explains the modification of the tolerance template that you can see here. After this change, which is equivalent to a proper and regular maintenance, the blue characteristic was plotted. You can see that the maximum airflow is well recovered, and we can see that the curve is slightly offset toward higher openings. This is something we observed in some cases. So most of the time the curve is inside the template, sometimes it's a little higher. I will come back to statistics later. And this shows that the aging of the component tends toward higher volume flows, which moves the trade-off between IAQ and thermal performances toward IAQ. From a health perspective, this is a better way to drift. Here is a second example. This is a kitchen unit that was installed in a bathroom. Same as earlier, the maximum airflow is reduced, this time by 32%, and this time the minimum airflow is also a bit reduced. But we still observe the correct reaction to humidity between 30 and 70%. so the active part, the nylon strip, is most certainly intact. When we change the passive parts, the grill and the shutter case, the performances are fully recovered. This time we are perfectly inside the tolerances. Superimposing curves like this is pretty interesting because you can see that the impact of the dirt on the device is almost completely vertical. Only the extreme volume flows are changed. So while the humidity range stays very close to what it is supposed to be. For comparison, we also characterize the auto-adjusted units. So for this product here on the y-axis, this is still the airflow. On the x-axis, this is the applied pressure difference. As expected for this type of units, the characteristic is rather flat. But in the absence of maintenance, the airflow is reduced here by 63%. Well, this is a constant reduction, so the IAQ is definitely not guaranteed. But when the unit is properly cleaned, the curve gets back, or mostly back, into the tolerance template. And that was the case for all the collected units. I just presented a few examples of characterizations. So here comes the statistics we extracted over all the collected units, along with our conclusions. So first, before cleaning, all the collected humidity-controlled exhaust units showed a conform hygroscopic behavior when the occupants haven't damaged them. Almost half the collected units still fit in the factory specifications, when the other half showed a reduction of the maximum airflow up to 34% due to clogging of the canal. But they still reacted to humidity, so as I said earlier, the episodes of pollution take longer to evacuate, but it gets done, and will still have reduced airflow when high airflows are not necessary. The accumulation of dirt almost only affects volume flow. Almost only affects the volume flows. The shift in hygroscopic behavior were all below 2% relative humidity in kitchen and below 5% in bathrooms. In conclusion, after 6 years of in-situ functioning, even without maintenance, humidity-controlled exhaust units still modulate on humidity, but the evacuation time for pollutants will depend on the level of maintenance. And if the units are properly maintained, so after the maintenance, this study shown that 75% of the units complied with factory specifications after 6 years of functioning, when the other 25% showed a slight increase of the airflow, lower than 3 cubic meters per hour in the kitchens and lower than 2 cubic meters per hour in bathrooms. In this regard, if the units are properly maintained, they will still ensure the design IAQ. And of course, the main conclusion to this study is that maintenance of ventilation units should be done properly and regularly. With this, I thank you for your attention. My colleagues and I will gladly try to answer any questions you ask during the presentation. So now my colleague will give me the list of questions I have prepared, and we will answer them. If you just give us a few minutes, thank you. So one question was, how do you determine if the IAQ is ensured? So for this particular study, we only looked at the components. So our way to affirm that the IAQ is ensured is simply to look at the characteristic, and if it's still inside the fabrication tolerances, we can say that the IAQ is guaranteed to be as designed. So this design IAQ is based on two things. The first thing would be the simulations that are done to authorize these systems to be commercialized, and the second time would be the monitorings, like the performance monitoring that has been done a few years back, and there will be another seminar on this subject in the next few months. So Adam asked, what is IAQ? That's a very good question. It means for indoor air quality, and in general, indoor air quality. It's a very complicated subject, but usually what we well, what we look at in regulations is the level of CO2. It should not exceed certain level, and it should not exceed certain exposure for the occupants. And the second criteria is on humidity. So the first one on CO2 is more for the occupants, and the second one is more for the building. We should not exceed a certain number of hours of condensation. Another question was, would you advise against installing auto-adjusting exhaust units? Well, I I wouldn't go as far. So the big difference between the auto-adjusting exhaust units and our hygroscopic exhaust units is that well, auto-adjusting exhaust units, they don't modulate, so they have a constant airflow. There is no we don't look at the IAQ, and there is no optimizing of the thermal losses. Well, on the contrary, these exhaust units that we talked about today, they are adapted to the need. They adapt the airflow to the need continuously. So they are really different in function. To make a link with this presentation, we saw on a former slide that we'll just put on the screen now. Yep. We saw on this slide that for the auto-adjusting units, there is a constant reduction of the airflow by about, well, in this case by 60%, and this is a constant reduction. So the indoor air quality cannot be ensured here. On the other hand, with our exhaust units, what we proved with this presentation is that excuse me. So the units are still modulating on humidity. So even after a long time of in-situ functioning, the units fit within the factory specification, and some of them only will increase the airflow, so it will go toward indoor air quality. So one question was, what was the manual shutter positioning during the test? So there is no manual shutter position, and it's only automatic. So Gail Guyot just asked, to your knowledge, is that the first study about ventilation units aging? Well, it's not the only one, but to my knowledge, at least, it was the first one. There is another there is another monitoring that is taking place. Well, let's say at the moment, but it's a bit different. It's a follow-up on the performance project, and this monitoring will be more about the full system. Here, well, in this one we focused on the components, and in the next one we will focus on the whole system. So we will more focus on IAQ, on thermal losses. Here we just checked if the units were still inside the specifications. I will first answer to the question that just popped up. So what about the air inlets? So here in this study we didn't look at it at all. The system here was well, I don't know if you are familiar with the French systems, but here it was a hygro A system. So the air inlets had a constant opening. There is also well, hygro B systems that were not here, and where we modulate the airflow of the inlets with humidity as well. And it will be the case in the performance monitoring study that I just talked about. just to give you a very quick feedback, because this is not in the scope of this presentation, but when we looked at the air inlets when we were in the apartments, we noticed that the maintenance was quite weak in general, and sometimes the air inlets were voluntarily obturated. Well, that's sometimes that we observe quite often. And Adam just asked, can you explain one more time why you were changing the tolerance range from higher to lower? Yep, this is a bit complicated. I will just go back to the slides where I talked about it. It was this one. Yep. So basically, some of the exhaust units were in really bad conditions, and we couldn't really repair them. Basically, after 6 years, it was impossible. Well, it was too much stuck. So what we did is we considered changing the grill and the shutter case that are here on the screen for new ones. And so the thing is, the regulation had changed between the installation and the collection, because it was 6 years before. And so we as manufacturer had to adapt our products to this new regulation. So the minimum and maximum airflow had changed between the old version and the newer version. We didn't have any of the old ones in stock, so we had to install the new ones. So basically, this is very similar to a maintenance, changing the shutter case like this. So one question is how regularly the units should be cleaned. So, well, it depends. Basically, it's when you see that it's getting dirty, but usually about once a year is enough. Spectator 28 just asked, do you have some precise prescription for air inlets as well as extract unit maintenance? Well, the way it works in France is with technical agreements. So depending on the size of your dwelling, well, whether it's individual dwelling or collective dwelling, you will have a precise prescription, yes. You have to look at what the technical agreement says, and you install what it said, and you should be fine. Yes, and for maintenance, well, for air inlets as well as extract units, as I just said, usually about once a year is enough. But if you see that the units are getting dirty or dusty, you should simply put the grill and shutter case in the in the washing machine, and it should be fine. Well, are there any other questions? It doesn't seem so. So I want to thank you again for being here today and for asking so many questions. If you had additional questions, you can send us, of course, an email. I will just put the contact here on the screen. If you want some additional information on this presentation, you can find the full paper that is available on the AIVC website, or you can ask us to send it to you. There will be a recast on YouTube that will be available, and I want to advertise a little bit for the next webinar that should be in the next few months about the aging of the whole system, as I said during the presentation. Well, thank you very much for your attention, and well, see you soon.